In an arithmetic progression, the sum of the terms that are equidistant from both the beginning and the end, that sum is always going to be equal to the sum of the first and the last terms. So let's begin. So here we begin by considering n numbers of terms and n number of terms that are in arithmetic progression. So let's say we have our first term as a1, our second term is given by a2, our third term is given by a3, and this goes all the way up to the last term, which is going to be the nth term. We're supposing that these terms are in arithmetic progression. That means they are going to have a common difference with a common difference of, let's call it d. Now, in all the nth terms, let's say we consider the kth term. The kth term from the beginning. So the kth term from the beginning will be represented by a k. So that's equals to the first term, which is a1, plus, since we have k number of terms here, so we'll have k minus 1 multiplied to the common difference d. So let's call it number 1. Then we are going to also consider, since we're saying the terms that are equidistant from both the beginning and the end, now we're going to consider the kth term, and now we will find out the kth term from the end of the arithmetic progression. So let's call it a k prime. Now we have to be a little bit careful here, since we're considering the kth term from the end. So what we can do, we can consider, since this is an AP, we can say that an, if this is the first term, then the next term will be an minus 1. Then we have an minus 2, and this goes all the way up to a3, a2, a1. We can say that this is also going to be an AP. Now, this is going to have a common difference of negative d, because we already defined that if we take a2 minus a1, we subtracting the first term from the second term. In our first case, our common difference is going to be positive d. Then in our second case, now a2 becomes the preceding term of a1. So here, if we do a1 minus a2, of course this is going to give us negative d. So we'll have a new common difference of negative d. So that means the kth term from the end will be equals to our first term. So what's the first term? That's actually the nth term. So we have an plus, since we're considering the kth term, so this is simply going to be k minus 1 times, now the common difference will be negative d. So this is going to be equation number 2. Now let's now add 1 and 2. So adding 1 and 2 simply means that we are adding the kth term from the beginning and add it to the kth term from the end. So this is going to be equals to the first term plus k minus 1 times d, plus the kth term from the end, which is simply an plus. Now here we have negative d multiplied to k minus 1, so we have negative k minus 1 times d. So here we can see that our second term and our fourth term cancels out, and this is going to leave us with the value, the first term plus the last term. So we have successfully showed that whenever we take the kth term from the beginning and add it to the kth term from the end, this is always going to be equals to the sum of the first term and the last term. So that means this is also going to be true for, let's say, if we take the second term from the beginning and we add it to the second term from the end. What's the second term from the end? So that's an minus 1. So if we do this, regardless of what we take, so this is also going to be equals to the first term plus the last term. Similarly, if we take the third term from the beginning and the third term from the end, which is an minus 2, so that sum is also going to be equals to the first term plus the last term.